we're going to revisit the HighLow Game sample because I don't really think I gave it what time class last time. So I'm going to start it from the beginning. We'll go over it. Hopefully we'll do a more complete job than we did last time. Just to introduce you, the HighLow Game is a very simple dice game where you roll 2 dice. Each dice has 1 through 6 dots on the side. And you try to predict whether the total of the dice is going to be in the high range, 7, or low. The low range is 2 through 6. So lowest that you can get with 2 dice is 2. And if it's 2 through 6, it's in the low range. 7 is by itself. And then 8 through 12 is considered the high range. So you predict what it is and you bet a token or whatever on it. If you win, if you pick high or low, and it is high or low, so if I pick high and it's an 11, for example, then I win. So I win a token. If I lost, I would lose a token. Same thing with low. If I pick low and it's 2, I win a token. Otherwise, I lose a token. The one exception to this is 7. If I pick that it's going to be 7 and it is 7, then I win 4 tokens because there's less chance it'll be 7 compared to high or low. And if I pick 7 and it's not 7, I only lose the 1 token. So that's how the game works. Now, one thing that's a misconception, I think, for students as we start GUIs is to forget everything that we learned the first half of the semester and think that everything is going to be in that GUI class. All right. That's not the case. The GUI is simply, could consider it sort of like the boss. It's what brings everything together. It does what the unit test did in our previous examples, where it creates members of a particular class. It creates objects and fills in the parameters for the objects and calls methods, and then takes the results and displays them. So in this case, if we were analyzing what objects we have, what classes we have a GUI class. All right, that's HighLow GUI. We have a dice class, and a dice class represents 1 die. All right, and 2 of them are rolled every time you play this game. Finally, we have sort of the game rules class. All right. Again, the better that you separate this out, the more reusable this could be. We could make, for example, a desktop application that plays this game. We could use the same classes in a mobile application if we wanted to. And we could use the same classes in a web application if we wanted to. So by breaking things down to different entities, and that allows us to write more reusable code. If everything was tied to the GUI, then we couldn't separate the GUI into multiple parts and reuse it. It would be an all or nothing thing. Either we use the GUI or none of the other classes are available. All right. So what I'm going to do in this is I'm going to imagine that maybe a couple people are working on this. Maybe 3 people are working on this project. And everyone is responsible for creating one of the classes. All right? Yes?
You like that in real life? That one
Oh, absolutely.
Okay.
Absolutely.
Isn't a project manager would put all the classes together?
Yeah, a project manager or a senior developer would put things together like that. But absolutely, this would be the case. And again, maybe like you'd have a specialist work on the GUI class, for example, because programming GUIs is sort of a different beast than programming regular sort of business classes. And each person, when they do their job, they're going to want to make sure that they do it correctly. So I don't want to turn in my code if the code has a bug in it or if there's something wrong with it. So I'm assuming that everyone wants to test their code thoroughly. Now, the people that create the problem domain classes, the dice and the HighLow game, can write a test class just like we wrote the first part of the semester. Person that created the GUI, well, they're going to bring everything together, as you mentioned, and their test will be more of a system test. We'll test everything in this little application together to make sure everything works as a unit. Because individual parts can work, but they might not talk together correctly for whatever reason. So let's look at these one at a time, and let's look at the code that I use to test them, and let's try to understand the rationale for that testing.
You want to do something like this in class when the semester's over? It's like get into groups and one person's assigned a class, another person's assigned a class.
You know, that wasn't in my immediate plans. I'll have to consider if that's a possibility. That would be good. It is a little tougher in sort of the blended high flex environment to do group work like this, but that would definitely be a possibility. In a way, you're sort of getting that with the pizza example, where the pizza classes are given to you and you have to write the GUI on top of it. Let's look at the dice class. Now remember, a class contains stuff that the class knows and stuff that the class can do. This has a constructor and two methods. There's a single attribute, and that is the value of a dice. If you think about it, what more do you need to know for a game than what the value of the dice is? That is, what is the number on top? You don't really need to know anything else. We have a constructor that will create the dice, and when it creates it, it will roll it just to give it an initial value. I could have made it have an initial value of 1 or maybe an undefined 0 value or something like that. What seemed most logical to me is when you create the dice, you randomly set it to one of the 6 possible sides. I have a roll which randomly generates a number between 1 and 6. Now, how do we get that number from 1 to 6? Well, if we look, math random returns a number between 0 and 5.9999999 repeating. All right. So if we truncated that and made an integer out of it, we'd have a number from 0 to 5. Because if we truncated 5.9999 repeating, we would get 5 if we just converted it to an integer. All right. And a dice, the spots on a dice doesn't go from 0 to 5, it goes from 1 to 6, and therefore I add 1 to the result of that and then truncate it. So this will give us a number 0 through 5.999. This will change it and give us a number from 1 through 6.9999, and this truncates it and will give us a value of 1 through 6. The get method simply returns the value that it currently is without rolling the dice. All right. Given the random nature of the dice, I didn't feel the need for having a set method in this. Why? It's very rare that you would say, well, I have a dice and I want it to be 2. You know, the dice is always a random thing. It's always rolled to get a value. Pardon me?
Saying so the set's not needed.
So a set, I wouldn't think a set would really be needed here. Because, I mean, in a dice game, you're not going to use it, you know. You could put it in. There possibly could be some use to it, maybe in another game or something. But
if you want to make a history for it, will the set be useful? let's say on the side of your game, you wanted a history of all the dice rolls to see, you know, how many highs versus how many lows versus how many sevens you have chosen.
Let's remember that question and we'll come back to it. All right, I promise we'll come back to it. But the question was, is what if we wanted to remember how many times it rolled high and low and so on? All right. So, or remember how many times someone won the game or lost the game or whatever, like a history of the game. So we'll think of both those kinds of things. The answer is yeah, you could have a history as part of the dice of these are the rolls. But again, that would seem to me to be required more on the game level than on the individual dice level. I wouldn't be, you know, how many times did this roll a 5, you know? Now, how are we going to test this dice? And what does a successful test result look like? Well, if we ran this, all right, we better get all the numbers from 1 through 6, and we better not get any other numbers. We better not get a 0 in there or a 7 or any other number. And we should get those about equally distributed. All right. Now, again, probability is such that, you know, there's a 50-50 chance when you flip a coin, but that doesn't mean that if you flip a coin 100 times, it's going to be 50 and 50. It might be 56 and 44 on one time, or 60-40 even, you know. But it's not going to be 90-10 when you flip a coin. Probably not, at least if you duplicated the test over and over again. So if I was the person that was writing the dice class, I would say, I want to test this out. And how would I test this out? I would test this out by making a dice test class. All it's going to do is test my dice. And all it's going to literally run and roll a dice 10,000 times. So I have a loop going from I equals 0 to I less than 10,000, increment I by 1 each time, roll the dice, then based on the value, I'm updating one of the accumulators. I have 6 accumulators for 1, 2, 3, 4, 5, 6. So I'm doing this as a test. I think I wrote code that randomly picks a number from 1 through 6. This is going to show me whether it does or not. Yes.
What happens if there was a 0 that popped in there?
If there's a 0 popped in, I know I have a bug in my dice class.
How would you see it?
How would I see it? That's a really good question. You got me there. We would know it. Here's how we could tell. All right. We wouldn't know it was a 0. And that's a good point. We should have a catch in there for that. All right. But a second way we could know is we could add up the number of occurrences. And that better be equal to 10,000. So if we add up the occurrences and it's 99 or 9,995 times, then there's 5 that are unaccounted for. And we know that there's a bug in that. But yeah, I probably would have a case of it being less than 1 and greater than 6 and increment it. Yeah. Great question. I have to admit that you got me on that. And yeah, about the only thing you could do the way it's written now would be to test and count the number of count the total number of rolls and add them up and make sure that it did equal 10,000. Probably do something like this. See, you intrigue me. Go like this case. Less than 1. I think that syntax is correct. So this is the better answer, would actually have an accumulator for it and make sure that they have no values when we do it with output. Zero. Counter 7.
On a normal job site, you would have something like this and you just have to test it, make sure there's no bugs before turning it into the senior.
I would think so. I would think so. And you know, that's one thing that I think that a lot of software developers, in my experience, don't do adequately is test. Now, this is a very simple class. It has a very simple job. It does one thing. But you want to test for as many possible combinations as possible. So, for example, if you were working with a database application, what happens if the disk is full and you try to do an update? What happens if you don't have permissions to access the database? What happens if the database engine is down? All these are kind of unusual conditions that you might not consider, but you should test for it, and you should test as thoroughly as possible. A lot of software developers I've worked with would test this by simply rolling the dice a couple of times and looking, yep, it rolled a 1, 2, 3, yeah, it looks about right, you know. Whereas a better software developer would write a little test routine. How long did this take to write? You know, 10 minutes, you know, once you think of the process. It didn't take very long to write at all. And it does a very thorough test because it literally tests all those combinations. One thing some of the students did is for the example, when we were calculating students' tuition, they actually put loops in their code and they set a student as being in county. Then they had a loop to go through and add and make 1 through 22 credit hours and call them each time. So they did a thorough test where they tested every possible combination of that. Then they did the same thing for out of county, the same thing for out of state. Yeah, and in doing that, they tested everything. So a little bit of effort in the testing goes a long way, in my opinion. Let's try to compile this. Hope I got the syntax right. I did not. Let's look this real quick. I don't want to spend a lot of time on it, but should. Can I use greater than or less than in a case statement? Oh, case. They're saying it's a value less than 1. Value greater than 6. Well, still it's like a Boolean cannot be converted to an integer. Well, I don't want to mess with this, but you could definitely put if statements in there to test for it if the case didn't work.
Statement.
Yeah, we could do that. Anyhow, onto more about this test. So I'm going to write, and I'm going to run it. And again, disregard those zeros because I didn't tally them up. And if we looked at this, let's see, that'd be 13, 22, and 8. It ends in a 0. So I'm guessing this adds up to 10,000. I could pull the calculator out and add it. But again, this looks like they're approximately equal. You know, if I run it another time, again, approximately equal. I'm not noticing that one is consistently higher than the other ones. So I could be pretty happy that the dice works.
Is there a way to favor, for example, if this is like a casino game?
Oh, that's a tough question.
I just want to know if it's possible.
Yeah, it's certainly possible to do that. We could, yeah, you could do that in any number of different ways.
After like 1,000 rolls, then it hits 7 instead of being random.
Right. Yeah, they definitely could be doing that. That wouldn't be very ethical, but yeah, they absolutely could do something like that. Okay, so we're happy with the dice class, and the dice class works. So on to the game class. Let's look at that. And the game class has 2 dice and has only one method, a play method. And the play method accepts an argument. Here's where comments would be good. Zero equals low. 1 equals 7. 2 equals high. So I have my exception here. Again, key thing with exceptions, catch the error as soon as it occurs. So if I call this method to play and I give it a 3, for example, or I give it a -1, immediately upon entering that play function, I should test to see if the argument is less than 0 or greater than 2. And if it is, throw an exception and say invalid option. Okay. So, assuming that the option is correct, we roll the dice, add the 2 up, set the payoff to 0. If the user chose low and the sum is less than 7, they win. I have an argument for bet here, even though my game assumes that you're betting 1 at a time. If the argument is, if the argument choice means that they pick 7 and they roll a 7, then their payment is 4 times their bet. Otherwise, their payment is -1 times the bet. And finally, if they pick high, if they rolled greater than 7, their payoff is their bet. Otherwise, it's -1. And we return the value of the payoff. So this accepts the user's choice and the bet and returns a payoff. It's very self-contained. We have these methods in here because at some point we're going to want to draw the dice up on the screen. So we're going to want to know the value of those 2 dice after we rolled it and determine if they won or lost. Because if the game simply said, you lost, but didn't show you what the choices were or what the dice that was rolled was, that wouldn't be too particularly good. Now I did a similar thing here, creating a test. I play 100 iterations, assume the bet is won, and I have a loop that does this 100 times that tells me what the dice was, what I picked, what I bet, and what the payoff is. I could write this different ways. I could have 3 loops, and in the first loop, pick low every time. In the second loop, pick 7 every time. In the third loop, pick high every time. That actually might be a better way to do it. I also probably should do a test where I give it an invalid selection to make sure that my exception handling works. And I don't do that here. But you see, I've done some kind of systematic testing to make sure that the game works at least pretty well. So let's look at that. And I can go back and make sure that the computer got it right. So there's my 100 results. I'm going to go through and look and verify that they're correct. I rolled a 6 and I picked 7. I bet 1, so I lost it. I rolled a 9 and picked high and bet 1. I get a payoff. I rolled 3 and picked high and bet 1. I lost. I rolled 6, picked 7, bet 1. I lose. And I can go and make sure that everything is correct, that it produces the results that I would expect it to. Now you might say, gee, this is kind of painstaking, all right? But it does ensure that it does go a long way to ensure that the data is correct. And when you're dealing with random stuff, sometimes you do have to test in this manner, where you run a bunch of tests and look to see the results. Okay, now we have both of those classes at work. Now to the main event, where we have our GUI. So let's take a look at our GUI here. First of all, let's run it to show you what the GUI looks like. There it is. Tells us how many points we have. Tells us to make our choice. Low, play. We lost, and that's the dice roll. Okay, let's notice what this looks like. because we're not going to spend tons of time talking about Java layout, but we should go over it to some degree. We're going to use these layouts where we're going to use panels. And these panels can be laid out panels can be laid out a number of different ways, but our panels can be laid out either vertically or horizontally. So I'm going to hold this up so I get the right for these things. I set my main panel P to be aligned vertically along the y-axis. I then have a number of things lined up in P. So P is going to be oriented this way. So my panel, things are stacked vertically. Now, what about in the case of the dice where I have the two dice side by side? Or what about in the case of here where I have make choice, a drop down, and a button? There's a label, here's a label, a drop down, and a button, and here's a label saying if we want or not. Notice how I do that. I have a panel called P choice. So P is this, which we stated is along the y-axis or vertically. So we put label points is the first thing we add to P. So that'll put label points on the top. Now, how do we get those next things to stack side by side? Shouldn't they be on top of each other? Well, we added those to a subpanel. So we added the label for the choice, the option list, and the button for play to a panel called P choice. Now, by default, panels are oriented horizontally. By having this line of code in here, we've chose to set the layout for P to be vertically. But all the other panels by default are oriented horizontally. So in that one, we added the label for choice, the options, and the button for play. So those three are put in a panel, and then that panel is added to P. So that allows this to be oriented horizontally, while the rest of the panels are oriented vertically. Label for results we add. That's this. And finally, the two die are added in their own panel. And that allows them to be placed side by side. So panels often have a simple alignment of either vertical or horizontal. But by adding subpanels within a panel, we can make things generally have the flow be vertical, but have some things side by side horizontally. And that's exactly what we've done here. Let's look at the options, because that's something that I don't think we did in previous example. We have a combo box, option list, and it gets us options from these strings, this array of strings. So that makes a drop down with these 4 things as options.
By the way, to set space between it.
Yes, there is. But again, that's something that you're welcome to play with and all that, but I would warn you not to spend too much time going down the rabbit's hole on that one, because it can be very challenging. All right. Now, the button. Somewhere here, I say the button's action listener is this. What does this mean? It means this object, whatever object it's in. How am I allowed to do that? I'm allowed to do that because we say this HighLow GUI implements action listener. Because it implements action listener, it means it can be used anywhere that an action listener is required, such as here. Now, I'm able to do that because I have an action performed method that accepts an argument of an action event. If I, for example, give this a different name, I will get a compile error. I get a compile error because I promised that this class implements action listener. That means that I need to implement all the methods that exist in action listener, and I did not. I did not implement the action perform method, and therefore I get an error. If I do not say that it implements action listener, I'm going to get a different kind of error. I'm going to get an error saying I can't plug this class into this statement. Why not? Because this class is not an action listener. Even though it has that action perform method in, it's not defined as implementing the action listener. So I can't use it wherever I need an action listener. But if I have both those conditions true, if I make this implement the action listener interface and I have the action performed, then this class can contain the action performed that handles what happens when the button is pressed. So I have an integer for user choice, bet, and payoff. Get selected index is going to return the position in the list of the item that's selected. So make choices is in position 0, low is 1, 2 is 7, and high is 3. All right. Now, if you remember, the class requires those values to be 0, 1, and 2. So what do? We subtract 1 from it. Because this will give us a number 0, 1, or 1, 2, or 3, and we want the numbers to be 0, 1, or 2. So we're going to hard code the bet to 1. We're going to call the play method on the game, get the payoff. If the payoff is less than 0, they lost. If the payout is more than 0, they won. I'm going to add to the points whatever the payoff is. I'm going to set the points label. And then I'm going to get the dice image by taking a D, putting in front of the value of the dice, and then adding a JPEG. If you notice in this folder, the dice have a D, the value of the dice, and .jpeg as the name of the file. And then I set the icon on those image icons to be that, and therefore I get those images displaying. Now your assignment, you're going to do something very similar to this, and you are welcome to use images, but you don't have to, where you're going to play rock, paper, and scissors. So do the same thing. Have a rock, paper, scissors class. All right. Have a choice class that both the computer and the user have one of those objects. Have a game class that accepts those objects, compares the values, and determines, is it a win, a loss, or a tie? I do have in Canvas a couple of things that might be useful to you. How to use radio buttons and how to use the scroll pane. The scroll pane is what we talked about of having a list of things. So review that example and see if you can integrate that into your labs. Now you asked the question, what if I wanted to keep a history? All right. If I wanted to keep a history, I have a couple choices where to keep it. I probably want the history either to be in the game class, so either in this class, HighLow Game, or in the GUI itself. Which would be better? That's a good question. If I viewed keeping the history as part of the game, like for example, when you play chess, all right? I don't play chess much, so I don't, but I do know that like there's notation that indicates each move. Okay, so that's important to the game, right? Because that tells you everything that happened throughout the process. So in a way, that's part of the game. That's the history of the game. I would include that in the game class. But if all we were doing is just displaying just so that the user could glance up and know, and I didn't really consider it part of the game, I probably would have it put it in the GUI. So I would consider, is it just something that we're doing visually to give the user something where they could review that? Or do I consider it like something important part of the game?
Okay.
And then I would decide. Like maybe, you know, if this was a football game, for example, you know, each score might be something important that I would want to keep associated with the game. So I could look back anytime I looked at this game. But if it was simply like this case where I'm rolling dice and the history of what happened isn't really important because each game is kind of standalone, I probably would put it in the GUI then, in that case.
Okay, so the GUI, they'll be able to see it.
The GUI would be able to show it to the user, and the user would be able to scroll through and they'd be able to look at and see, like, gee, I played high a bunch of times and I won, or I played 7 and I lost, or whatever.
And then if you put it in the actual game class, then it could be seen, but it's more in the background.
Yeah, more or less, I would say that's correct.
I noticed when I kind of changed the code to where I can put in a bet, there's no game over, so it just goes to negative. That's what's supposed to happen.
In this,
Dice game.
in the dice game, yeah, I don't have any. You can go into debt in this game, yeah.
Okay, I was just asking to make sure I didn't change anything I wasn't supposed to be changing. I didn't play it all the way down when it was the regular code, so I just kind of moved it around. And as I was running it, I was like, wait, I'm in the negative now. So,
Right. That would be something you could add after every game. Look to see the balance. If the balance was 0, pop up a game over message and disable maybe disable the button so that they can't play again, or ask them if they want to play another game and then reinitialize values or something like that.
Okay. Okay.
All right. That's it for today. If you have questions, please let me know now. Otherwise, we will either see you in lab or see you in class next week. All right. Well, take care. We'll see you either in lab or next week.